Welcome to Spaceverse, your portal to cosmic adventures. Neil deGrasse Tyson once said, "The universe is not only bigger than we can imagine, under most scales, it is bigger than we can imagine." And isn't that just mind-blowing? It gets you wondering. Does the universe have a beginning and an end? Did the incredible James Webb Space Telescope finally spot the edge of the observable universe? Humans have always been obsessed with figuring out the size of the world we live in. Ages ago, the edge of the world was just over the horizon. Fast forward to today, and we've swapped compasses for telescopes, exploring the universe to uncover whether it's truly finite. And with the James Webb Space Telescope, we might just be on the brink of a major breakthrough in this age-old quest. But here's the kicker. The question isn't whether the universe has an edge, it does. The real mystery is what that edge means. Could it be the true end of everything? Or perhaps a gateway to another universe? Maybe even a passage into unknown dimensions? The possibilities are as endless as the cosmos itself. Think about it. Earth has boundaries, as do our solar system and our galaxy. Yet, the universe? It just keeps going. Tyson hit the nail on the head when he said the problem isn't the universe, it's our perspective. Our imaginations, as vast as they might seem, are still limited compared to the infinite grandeur of the cosmos. So, while we continue to search for the universe's edges and beginnings, we do so with tools that are still in their infancy compared to what's out there. And that's what makes this journey so thrilling. Who knows what wonders await us beyond the stars? With our telescopes, humanity is currently peering an astonishing 46.5 billion light-years in every direction. That's a mind-boggling total of about 93 billion light-years across. Yet, even within this immense expanse, there's no end in sight. The stars, galaxies, and cosmic phenomena we've discovered within this observable universe are beyond imagination. Exploring and understanding every corner of just this known expanse would take us thousands of years. But let's be honest, we're a curious bunch. That insatiable drive to know more keeps us looking further and further into the great unknown. We want to know, does the universe have an edge? What does it even look like? The James Webb Space Telescope might finally bring us closer to these answers. So, does the universe have a beginning? Neil deGrasse Tyson adds an intriguing layer to this puzzle. The James Webb Space Telescope identifies objects in the darkness that, according to the best measurements we have, are large, fully developed galaxies. Here's the thing, humans are wired to think in terms of beginnings and endings, facts and figures, and neatly confined spaces. But the universe laughs at these boundaries. Anyone who studies the cosmos quickly realizes they're up against the limits of human thought and perception. To truly grasp the unimaginable dimensions of the universe, we have to push the boundaries of our understanding. The sheer scale of what we've seen so far, the endless stars, countless planets, and the strangest cosmic phenomena forces us to open our minds and embrace the infinite. Astronomers and cosmologists might seem like the ultimate open-minded explorers of the cosmos, and they are. But even they must face an uncomfortable truth. They too are limited by the boundaries of current knowledge and thought. The James Webb Space Telescope is here to challenge those boundaries. With every discovery, it's pushing scientists to their intellectual and conceptual limits. Theories we once held as truths are starting to wobble. It's not unlike the leap humanity made hundreds of years ago when we realized the Earth was round, not flat. Could we be on the cusp of another seismic shift in our understanding of the universe? Let's talk about one of JWST's jaw-dropping revelations. 6 galaxies so ancient and so perfectly formed that their very existence shouldn't be possible within the timeline we thought we understood. JWST was designed to peer into the universe's dark ages, the epoch when the first stars and galaxies began to form. But instead of spotting protostars or baby galaxies, Webb delivered something completely unexpected, rows upon rows of mature, fully developed galaxies. This raises a tantalizing question. Are we truly observing the universe's temporal edge? And even more intriguingly, did the so-called dark ages of the universe actually exist? Or was it simply a concept born of our ignorance? But the surprises don't stop there. JWST also uncovered a massive cluster of galaxies that existed far earlier than we thought such clusters could form. Millions of galaxies in tightly packed groups, existing when the universe was supposedly still in its infancy. This defies the traditional narrative. Individual stars form first, followed by star clusters, galaxies, and then galaxy clusters. So what story is this early galaxy cluster trying to tell us? Neil deGrasse Tyson captures the crux of the issue perfectly. The problem is not the universe. The problem is us, because we think we know more than we actually do. With each discovery, the JWST reminds us how much more there is to learn and how much further we must expand our minds to grasp the truth of the cosmos. Believe it or not, the James Webb Space Telescope keeps uncovering more galaxies from an era we once called the Dark Ages of the universe. Almost all of these early galaxies have a redshift greater than 10, meaning they existed when the universe was just 2% of its current age, a few 100,000 years after the Big Bang. But here's the twist. These discoveries don't reveal a dark universe. Instead, they show us a cosmos that looks surprisingly familiar, resembling much of what we see today. The findings were so extraordinary that scientists initially doubted them. Could this really be possible? However, the JWST's spectroscopy capabilities have confirmed every result time and time again. For those unfamiliar, spectroscopy is like breaking light into a cosmic fingerprint. By analyzing the different wavelengths, astronomers can determine the distance, age, and even chemical composition of an object. The surprising takeaway? These galaxies are not just ancient. They contain stars and elements that challenge our understanding of what the young universe should look like. As we push the boundaries of time, the universe's temporal edge continues to move further away from us. But what about its spatial edge? Does one exist? And if so, how can we find it? Here's the paradox. To locate something in present-day space, we need to observe it in real time. Imagine you're in a pitch-black concert hall with just a few tiny lights scattered around. You don't know how large the room is or where the walls are. To find the edges, you'd have to explore the space by touch or feel. For now, exploring the universe is like being in that dark concert hall, but instead of using our hands, we rely on telescopes like the JWST. And as these tools improve, so does our ability to uncover the cosmic unknown. Exploring the cosmos is a bit like trying to find the walls of a massive, dark room without actually being able to walk around it. Since we can't physically travel through space yet, we rely on telescopes like the James Webb Space Telescope to peer further and further into the unknown. These telescopes focus on the bright spots, like the LEDs in our metaphorical room, because that's where we can gather the most information. But here's the catch. The universe isn't sitting still while we observe it. It's expanding like walls moving outward as you try to study them. This means our technology has to keep up with the universe's relentless growth to stay in the race. And there's another challenge. The light we see has taken years, sometimes billions of years, to reach us. With the JWST, we're looking at light from stars and galaxies that may be hundreds, thousands, or even 13 billion years old. In other words, we're always looking into the past. In everyday life, we don't notice this time delay because light from something nearby, like a lamp, reaches us almost instantly. But in space, light's journey takes so long that we're always seeing things as they once were, not as they are now. For example, the light from Alpha Centauri, the closest star system, takes 4 years to reach us, so we're seeing it as it was 4 years ago. Based on what we know, we can confidently say the universe was smaller billions of years ago because it hadn't expanded as much. Yet, despite all our advancements, we've found no signs of a true spatial boundary. What we have discovered is that the universe doesn't expand uniformly. Some regions stretch faster than others, suggesting that the cosmos might not be as simple or homogeneous as we once thought. JWST, a journey into infinity. Have you ever wondered if searching for boundaries or a beginning might be the wrong approach? Perhaps this new chapter of space exploration is urging us to think beyond the confines of limited dimensions and challenge what we've accepted as true. The James Webb Space Telescope is proving time and time again that limits, even within the universe, may not exist. Recently, Webb observed a distant galaxy and uncovered something extraordinary, a massive active galactic center that left scientists stunned. This young galaxy, formed just 570 million years after the Big Bang, houses a quasar powered by a black hole 10 times the mass of our Sun. These active galactic nuclei emit dazzling light, created by the intense friction of spiraling material falling into the black hole. They shine trillions of times brighter than even the brightest stars, breaking every expectation of what should exist so early in cosmic history. The JWST also challenges us to expand our understanding of exoplanets. Take HIP 65426b, for example, a colossal gas giant over 12 times the size of Jupiter. Although it was first identified by Hubble in 2017, Webb's advanced technology has provided unprecedented details about this planet. Located a staggering 100 times farther from its star than Earth is from the Sun, it lies at more than twice the distance of Pluto from our Sun. For the first time, Webb's instruments, coronagraphs, cameras, and filters captured a direct image of this planet. This is a remarkable feat, as most exoplanets are discovered indirectly, either by their transit in front of a star or through gravitational effects. These discoveries highlight just how limitless the universe truly is. From quasars blazing with unimaginable energy to planets defying traditional detection methods, Webb reminds us that the cosmos is filled with phenomena, exceptions, and dimensions we're only beginning to explore. The search for an end or a limit seems almost futile when the universe offers so much diversity and infinity. And that's it. Thanks for joining us on this cosmic journey with Spaceverse. The universe has no limits, and neither do we. Don't forget to like, subscribe, and stay tuned for more incredible discoveries.